Assalamualaikum. I respect the lecturer of the subject MEM435, Computer Edit Design, which is Dr. Hafiz. I am AHMAD bin ADNAN. I'm from Invizo Groups. Would like to present our mini project, which is Gyro-Lit motorcycle. There are the names of group members. Let's show the introduction. To fix urban traffic, we need vehicle that both eco-friendly and practical. This project involves designing a hybrid motorcycle that combines fluid efficient gas engine with electric motor. Managed by a smart energy management system, the bike can switch between different modes. First, all electric for silence or zero emission city riding, and then second, power mode for better performance by using both engine together. So by offering this flexibility, the motorcycle serves as a sustainable and versatile alternative to traditional gas power transport. Show the problem statement. First, the line design strip. Currently, stylists and engineers work sequentially rather than simultaneously. Stylists create a visual concept first, and engineers only review it later to see if it's actually built it. And then three major consequences. First, stifled innovation. So design play it safe and strict to boring, designed to avoid engineer rejection, killing truly original idea. And then wasted resources. It means constant back and front review create cycles or deviation, then inflated costs and delay the product releases. And then lastly, about the compromise quality. It means the final motorcycle often end up being watered down visual of the original vision, failing to provide the product balance of beauty and performance that riders expect. Show the design objective. First, dynamic and aesthetic. It means create a design that look great, clearly show the motorcycle personality, whether it's a sporty bike or rugged explorer. Next, ergonomic, optimize ride comfort and control. It means make sure the handlebar, seat, foot page, place it perfectly so the rider feel comfortable and in total control. And so the bike should feel natural to sit on the fit the body size of the specific riders it was built for. And then next point is about ensure engineering viability and structure integrity. It means design every part and the main frame so they're easy to build and strong enough to be safe and reliable on the road. So the next point is smart and seamlessly. It means combine beauty and purpose by ensuring every design feature help cool the engine, improve aerodynamic and protect both the riders and the bike's internal ports. And then so last point is about develop a unique and user-centric identity. This means create a unique look using specific like the color and material that make the brand stand out and make the owner feel proud to own the bike. I will show about product justification. There are several types of motorcycle. Show about petrol motorcycle with motorcycle without windshield, and then electric motorcycle. This page show about motorcycle with windshield and motorcycle about brake system by using disc brake. This page show about the motorcycles by using system brake by using drum brake, and then the motorcycles using stabilizers with two wheels. This page show about motorcycles by using system stabilizers with gyroscope system.
Hello, my name is EUSOFF ISKANDAR. For identify problems, we have three categories. The first one is weather exposure. The problem is rider is fully exposed to weather conditions such as rain, sun, wind, and cold. The need is the integrated roof provides a physical barrier against rain and direct sunlight to keep the rider dry and shielded from the harsh UV rays. For second category is rider visibility and safety. Problem is reduced visibility and distraction in heavy rain due to wet or fogging helmet visors. For the needs, the windscreen integrated into the roof provides a fixed, larger and potentially wiper-equipped clear view, reducing reliance on the helmet visor and improving focus. The last one is rider fatigue. Problem is constant wind buffeting and air resistance, especially at higher speeds. Need is the aerodynamic design of the canopy deflects direct wind pressure away from the rider, significantly reducing buffeting and contributing to a less fatigued ride. Next is benchmarking. Here we have three motorcycles, which is Yamaha NVX, second one is Honda ADV, and the third one is Yamaha X-Max. For the price, for Yamaha NVX, it is around 9,600 ringgit to 11,500 ringgit. For Honda ADV, it is around 20,000 ringgit to 25,000 ringgit. And for Yamaha X-Max, it's a little bit high, around 25,500 ringgit to 31,800 ringgit. For weight impact, Yamaha NVX, it is very light, around 118 kg, due to its material usage, compact design and its target as an agile city scooter. For Honda ADV, it is light, 133 kg, due to the compact scooter-based frame rather than conventionally heavy chassis. For Yamaha X-Max, it is heavy, around 180 kg, due to its design as a premium long-distance maxi scooter with robust chassis. For aerodynamics, for Yamaha NVX, it is moderate, sharp and streamlined bodyline, and update side covers. For Honda ADV, it is very poor because it has boxy design, not built for high speed and efficiency. For Yamaha X-Max, it also poor. It often creates high drag and dangerous crosswind vulnerability. The advantage for Yamaha NVX, most agile and easy to commute in small and crowded places. For Honda ADV, it is suitable for short and long distance with its acceptable size. For Yamaha X-Max, it has great power to weight ratio with decent storage capacity to store essential things. Okay, for the product new design, the first one is aerodynamic body shape. To make it more aerodynamic, the aerofile shape is the most suitable shape. This shape will maximize its efficiency through wind tunnel testing, thus making it capable to travel even further with a full tank of fuel or a single charge. The second one is lightweight material. By using lightweight material such as aluminium or carbon fiber, it can reduce the stress for the battery or the engine to carry the load of the motorcycle. The lighter the motorcycle, the easier it is to be faster and quicker to reach its top speed and acceleration. This also can significantly reduce fuel or battery consumption.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad IRFAN ZAKWAN bin Muhammad ZAIRIL. I'm going to present the product ethical principle session. So what does product ethical principle means? Means that as any modification to this motorcycle can carries an inherent risk of alternating its fundamental dynamics. To be simple, if any modification has been made to the product, such as this motorcycle, it can be the consequences whether it's good or not. So first of all, the requirement to avoid harm. The canopy must not introduce new unforeseen hazards like instability, excessive crosswind sensitivity, or vision obstruction that outweigh the benefit of weather protection. So, to counter this, we can conduct rigorous aerodynamic simulation and physical stress testing to ensure the canopy remains structurally sound and safe at maximum highway speeds. The second one is transparency and risk disclosure. So, be transparent about the limitations of the product. For example, the maximum safe speeds with the canopy attached and performance limitations in extreme crosswinds. So, to counter this problem, we can provide clear, prominently displayed warnings and users instructions detailing wind limits and proper installation or detachment procedures. And the final one is usability and ergonomics, which means the design must ensure the rider's line of sight, forward and peripheral, is never compromised, especially when cornering. So, we need to design the windscreen with minimal glare and geometry that avoid distorting the rider's field of view. With this, we can ensure the canopy does not interfere with the natural steering and lean motion of the motorcycle. So let's move on to the finite element analysis, which consists of absorber, fork, arm, double stand, and shaft. For the first component is the absorber. The material selected for this absorber is steel. The simulation was conducted under fixed constraints to analyze the structural integrity. A tensile load of 10,000 Newton was applied to the part to determine the stress distribution and to identify the potential failures. According to our data, the maximum von Mises stress is 1.35 times to 10 power of 5 Newton meter square. The figures also shows that the area bounded by the blue colors are the least displacement after applying distributed load, which is 0. Meanwhile, the red colors are the most displacement after applying distributed load. This shows that the stress is applied on the areas are not the same. The next part is the fork. The material that is commonly used for this component is steel. The boundary conditions for these parts are clamped at the stem that holds the fork. The distributed load given is also 10,000 Newton on the fork. According to our data, the maximum 1 meter stress is 1.66 times 10 power of 5 Newton meter square, while the minimum 1 meter stress is 0. The displacement analysis also shows how the fork deforms under the given load. The maximum displacement occurs at the top of the fork tubes, which is expected as they are the furthest from the fixed constraints. The maximum displacement is 0.000124 mm. Moving on to the arm, the material selected for this swing arm is steel. The stress analysis identifies how the swing arm handles structural loads. The highest stress concentrations are located near the pivot junction, where the two arms meet the main mounting block. According to our data, the maximum 1 meter stress is 5.34 times 10 power of 5 Newton meter square, while the minimum is 88.7 Newton meter square. The displacement magnitude indicates the physical flex of the arm under the load. The maximum displacement occurs at the furthest tip of the arm, as these points are the greatest distance from the fixed pivot. The maximum displacement is 0.000438 mm. Moving on to the double stand, the material selected for this component is also steel. Boundary conditions include fixed support at the 4 base contact points where the stand meets the ground. A distributed vertical load is applied to the upper mounting bracket, simulating the weight of the motorcycle frame pressing down on the stand. The stress analysis identifies how the stand handles the static weight of the vehicle, which is the motorcycle. The maximum stress concentrations are primarily located at the upper mounting cylinder and the primary structural joints. According to our data, the maximum 1 meter stress is 2.3 times 10 power of 5 Newton meter square, and the minimum value is 3.0 T times 10 power of 008 Newton meter square. The displacement magnitude shows the physical deformation of the stand under the motorcycle's load. The maximum displacement is centered at the top mounting point, which is the area furthest from the rigid ground supports, with the max displacement is 0.000464 mm. For the final component is the shaft. The material chosen for the shaft is also steel. For this simulation, the boundary conditions include fixed support at both ends of the shaft, where it would typically be mounted within the bearings or housings. A distributed load is applied downward along the central length of the shaft to simulate the weight or torque-induced forces it must support during operation. The stress analysis identifies how the shaft handles structural bending. The maximum stress is concentrated at the fixed end support, which is typical for a beam-like structure under a distributed load. According to our data, the maximum 1 meter stress for this particular part is 1.76 times of 10 power of 005 Newton meter square, while the minimum is 1.28 times 10 power of 004 Newton meter square. The displacement magnitude indicates the degree of flex or bending in a shaft. As expected with fixed ends, the maximum displacement occurs at the center of the shaft, furthest from the supports, while the maximum displacement is 0.000167 mm.
Hello, my name is Muhammad bin Zulkifli. The next slide, I will be presenting about contribution of society. The first is lowering emission. For example, by increasing the year-round utility of motorcycles, which generally have lower fuel consumption and smaller footprint than car. The next is increase the productivity. Riders can work longer and more consistently during heavy rain, directly increasing their income and ensuring faster, more reliable service for customers. The lastly is health and comfort, protecting rider from direct sunlight, reducing heat exhaustion and sunburn, and heavy rain, reducing the risk of hypothermia or illness, contributes to the overall health and well-being of the community public. For the next slide is technical drawing. For the first slide is projection view of motorcycle. This is the front view of motorcycle, left view, and top view. The next slide is isometric view. This is the only assembly for the motorcycle. The next slide is wireframe view. This slide, I would like to show you the area where the gyroscope is located. The gyro is yellow color at the middle point on the motorcycle. The lastly is exploded view. The exploded view, we have the 25 part of the drawing, and one part is assembly is the sport rim. The sport rim is like sport rim, disc, and tires. In conclusion is motorcycle by integrating a sophisticated parallel hybrid electric powertrain with a user-focused design approach. This project successfully bridged the gap between aesthetic innovation and engineering feasibility to deliver a sustainable, all-weather transportation solution that optimizes rider comfort, structural safety, and environmental efficiency for the future of urban mobility.